Good afternoon, Internet. I am Matt Booyak, and in this video, we'll be taking a look at the 42nd problem from the Project Euler problem archive. Now, this problem asks us to consider a file with roughly 2,000 common English words and to interpret the characters in each word as numbers with A corresponding to 1, B corresponding to 2, etc. And to add the letters from each word to give each word a score, and then to identify the number of words which have a triangular number as their score. And you'll recall that triangular numbers are just those of the form 1/2 times n plus 1. So I think this problem is pretty straightforward, so let's get into it. Now I'll note that I've already taken the liberty of downloading this file, p42words.txt, that has the words that we need. So let's begin by copying our template directory to make our problem directory. We'll then move our words file into our problem directory, but we're going to rename it as p42words.h instead of .text. That is, I don't want to have to bother with reading from a file, so I'm just going to make a header file that has all the words in it. Now go into our problem directory and open up our main.cpp. We'll start by including p042words.h, like so. And let's go over and take a look at that list of words. You'll see it is indeed a giant pile of words. So let's see if we can change this to a form that we can actually use in our program. In particular, we're going to store it as a vector of strings. We could store it as an array, but avoiding native C-style arrays makes certain tasks easier, so we're going to use a vector instead. So we'll say vector and string. And then we'll say const std vector, std, it is certainly chugging a bit, string, and we'll call that just words. That's going to be equal to all of this. Okay. Let's go back over to our main.cpp. So we're going to need a way of calculating the score of a given word. So let's start by doing that. We'll say int score word. And so we're going to take a reference to a string. And we'll say for each character in the string, I'll need to keep track of our score. And so we'll say score plus equals ch minus a plus 1. So this is just the character code for a, and so subtracting that will give us the number of steps into the alphabet that our character is. So for A, that would be 0. For B, it would be 1. But then we need to add 1 because A corresponds to 1 in our scoring system, not 0. All right, and then we just return score. We'll also need a way to determine whether a number is a triangular number or not. So let's do that. Bool is triangle at int n. Now, we could just try each of the triangular numbers until we get to one that is greater than our target number here. But that's not particularly interesting, and I think this video will be quite short as it is. So I'm going to take the opportunity to show you an interesting technique for checking whether a number is part of a given set of integers or has some particular property. You can also use this, for example, to find the square root of a given number. And the way we're going to do that is to store our triangle numbers in a vector that will persist between invocations of this function, and then we'll just binary search that array to find out whether our number is a triangular number or not. As I said, a little bit overkill, but it shows an interesting technique, so I'm going to do it anyway. So we'll say static std vector of integers. We'll call these triangles. And we'll say while triangles dot empty or triangles dot back is less than n. We'll get the number that corresponds to the triangle number that we need to add. So, for example, if we already have 2 elements in the array, those would correspond to 0 and 1, the first 2 triangular numbers. So we would need to get the the third triangular number, which is 3. And we're going to do that by saying int m is equal to triangles.size, and then doing triangles.pushback m times m plus 1 over 2. Now, it may seem at first glance that this code is defeating the whole purpose of our binary search strategy. But keep in mind, this only has to be done once. Once we've generated our triangle numbers up to a certain point, we will just skip over this immediately because the largest triangle number will be greater than or equal to n. All right, so now we can just say return star std lower bound triangles dot begin triangles dot end, and we're looking for the value n, and we're checking to see if that is equal to n. So what is going on here? There's a good chance you don't quite follow what I just typed here. So let's take a look at this lower bound method here. So the idea of this function is that it's going to use binary search on a sorted array to find the first value that is not less than our target value. So that means it's going to be either equal to our target value, or if our target value is not in the array, then it will be greater. It will be some other value. And so if our number is if our number n is a triangular number, then it will be in the array, in which case the value that is returned will be equal to n. So this is checking to see if n is a triangular number. Note that the function returns an iterator rather than the value itself, and that's why we need this star here out in front. Okay, so now we can just iterate over our words, score them, check to see if they are triangular. So we'll say int solution is equal to 0. And we're going to say for std string reference, const string reference str in words. We'll say if is triangle score word str plus plus solution. That is, we found a word with a score that is triangular, so increment our count. And lastly, we'll just say printf solution is solution. And that should be good. Oh, wait, I just remembered I haven't actually included algorithm here. In order to use that lower bound method, we need to include algorithm. Oh, always like it when it compiles on the first try. And it says that our solution is 162. So let's go back to the archive here and scroll down to problem number 42. And we can see that our answer is, in fact, 162. So as always, thank you for watching. And in the next video, we will tackle problem number 43.